Hi everyone, I am Renju Francis, Assistant Professor, Department of Basic Science and Humanities, Jyoti Engineering College. I am going to deal with the topic Laplace transform. A topic on Laplace transforms. Laplace transformation is a very powerful technique that it replaces operations of calculus by operations of algebra. For example, with the application of Laplace transform to an initial value problem consisting of ordinary or partial differential equation together with initial conditions is reduced to a problem of solving an algebraic equation. It is very useful in obtaining solution of linear differential equations, both ordinary and partial differential equation. So without the necessity of first determining the general solution and then obtain the particular solution, we can find the solution of non-homogeneous differential equation. So here are some applications. One important feature of the Laplace transform is that it can transform analytic problems to algebraic problems. It also converts integral and differential equations into algebraic equations. It transforms a function of a real variable t of a time to a function of a complex variables. Laplace transform is applicable not only to continuous function but also to piecewise continuous functions, complicated periodic functions, step functions, impulse functions, etc. So here is the definition for Laplace transform. If f of t is a function defined for every t greater than or equal to 0, the Laplace transform of f of t is denoted by L of f of t or f of s, which is defined as L of f of t equals integral 0 to infinity f of t e raised to minus st dt, which is equal to f of s. It is an integral transform. Here L is called Laplace transform operator, but the function f of t is known as a determining function which depends on t. The new function which is to be determined, that is f of s, is called generating function which depends on s. Here the sufficient condition for the existence of Laplace transform is that f of t should be continuous or piecewise continuous in the given closed interval. The other one is f of t should be in exponential order. So using these sufficient conditions, we can use Laplace transform to solve the differential equation. So to find Laplace transform of a function f of t, here you can use this integral formula, integral 0 to infinity f of t e raised to minus st dt. So here are some examples. Find Laplace transform of 1. To find Laplace transform of 1, we can apply the formula integral 0 to infinity f of t e raised to minus st dt. Here f of t you can replace it as 1. So integral 0 to infinity 1 into e raised to minus st dt. That is, here you have to integrate e raised to minus st. Here the integral of e raised to minus st is what? E raised to minus st by minus s within the limit 0 to infinity. Now you have to apply upper limit and lower limit. If you are putting upper limit, you will get what? E raised to minus infinity minus, if you are giving lower limit, e raised to minus 0 by minus s. We know the value of e raised to minus infinity. E raised to minus infinity equal to 0. E raised to minus 0 equals 1. 0 minus 1 by minus s equals 1 by s. So here the Laplace transform of 1 is 1 by s. Now we go to the next example to find Laplace transform of e raised to at. Here the same formula you can apply, integral 0 to infinity f of t e raised to minus st dt. Here you replace f of t by e raised to at. So this becomes integral 0 to infinity e raised to at into e raised to minus st dt. Now here you can combine these two exponential function. So integral 0 to infinity e raised to at minus st dt. That is equals integral 0 to infinity e raised to, take negative t outside. So minus of s minus a into t dt. That is equals e raised to minus of s minus a into t, integral is e raised to minus of s minus a into t by minus of s minus a within the limit 0 to infinity. If you are giving upper limit and lower limit, you will get the numerator as minus 1 by minus of s minus a. That is same as 1 pi s minus a. That means Laplace transform of e raised to at is what? 1 pi s minus a. Suppose we have to find Laplace transform of e raised to minus at. There you replace f of t by e raised to minus at. And here it is e raised to minus at by minus st. Then take minus t outside, so this becomes s plus a. Then finally you will get what? L of e raised to minus at equals what? 1 pi s plus a. Got it? So the difference between L of e raised to at and L of e raised to minus at, here it is, in the case of L of e raised to at, this is 1 pi s minus a, and L of e raised to minus at is 1 pi s plus a. Next example is to find Laplace transform of L of t. Again, you apply the formula integral 0 to infinity f of t e raised to minus st dt. That is equals integral 0 to infinity f of t, you replace it as t e raised to minus st dt. Now, you do the integration by parts and you will get t into e raised to minus st by minus s minus 1 into e raised to minus st by minus s whole square within the limit 0 to infinity. That is same as if you are putting t equal to infinity, this full term will become 0. That means e raised to minus infinity is 0. So this full function will become 0. Minus putting t equal to 0, this first function will become 0 and this will become 1 pi s square. So by applying upper limit and lower limit, we will get 0 minus 1 pi s square. That is same as 1 pi s square. So Laplace transform of t is 1 pi s square. Now we will find the Laplace transform of sin omega t. Again you apply the formula integral 0 to infinity f of t e raised to minus st dt. That is equals integral 0 to infinity f of t is what? Sin omega t e raised to minus st dt. That is equals, applying integration by parts and simplifying, we will get omega by s square plus omega square. So Laplace transform of sin omega t equals omega by s square plus omega square. We go to the next example to find Laplace transform of cos h at. This is a hyperbolic function. We know that cos h at equals e raised to at plus e raised to minus at by 2. This is same as you take negative 1 pi 2 outside. So 1 pi 2 into L of e raised to at plus L of e raised to minus at. That is equals 1 pi 2 into L of e raised to at is 1 pi s minus a plus L of e raised to minus at is 1 pi s plus a. By doing LCM and simplifying, we will get 1 pi 2 into 2s by s square minus a square. Cancelling this 2 and finally the answer is what? S by s square minus a square. That means Laplace transform of cos h at is s by s square minus a square. Now we go to the Laplace transform of some elementary functions. We can find the Laplace transform of some elementary function using the same formula integral 0 to infinity f of t e raised to minus st dt. That I have shown some examples before, that is L of 1 equal to 1 pi s, that we have already done it and we got 1 pi s. Similarly, we can find the Laplace transform of these elementary functions, and here we got what? L of t equals 1 pi s square, L of t square equals 2 factorial by s cube, L of t raised to n equals n factorial by s raised to n plus 1, then L of e raised to at equals 1 pi s minus a, then L of e raised to minus at equals 1 pi s plus a. L of cos omega t equals s by s square plus omega square. L of sin omega t equals omega by s square plus omega square. Then L of cos h omega t equals s by s square minus omega square. L of sin h omega t equals omega by s square minus omega square. L of e raised to at cos omega t equals s minus a by s minus a whole square plus omega square. Then at last, L of e raised to at sin omega t equals omega by s minus a whole square plus omega square. So these are the standard functions that we can find Laplace transform. We go to some properties. The first property is linearity of Laplace transform. Here, L of A into f of t plus b into g of t. Here, A and b are constants. So, in order to find Laplace transform of A into f of t plus b into g of t equals A into L of f of t plus b into L into g, b into L of g of t. Now, next property is first shifting theorem. If L of f of t equal to f of s, then L of e raised to at into f of t equals f of s minus a. So, in order to find L of e raised to at into f of t, first of all find L of f of t. That is what f of s. There you replace s by s minus a if there is e raised to at. If it is e raised to minus at, there you replace by s plus a. The Laplace transform of f of t, there you replace s by s plus a. So, L of e raised to at into f of t equals f of s minus a, and L of e raised to minus at into f of t equals f of s plus a. So, these are the two properties of Laplace transforms. Thank you.